Now, by way of example, we want to follow a process fault during runtime through the schematic automation system from address monitoring in the ladder, function block diagram or statement list user program via S7-P-Diag to display on the HMI device by Pro Agent. On the CPU side, our model consists of the user program level and the operating system functions. An HMI device with Pro Agent is connected via the relevant hardware controllers and bus systems. Let us presume that the various process states are read into the automation system via appropriate sensors. In one particular program logic, these signals are linked in one central release signal. Address monitoring for this release signal has been configured with S7-P-Diag. As mentioned before, the S7-P-Diag option package generates the functions and instance data blocks for this configured address monitoring. The first function block has the task of monitoring the address in its setpoint state. The second function block stores at the time of fault the state of all the signals that make up the result of logic operation of the address being monitored. The fault recognition FB monitors the addresses in the cyclic program in the user block for which the monitoring has been configured. Let us now assume that one of the sensor signals takes on a fault status. As soon as the result of logic operation shows a deviation from the setpoint state, the fault recognition mechanism stores all the signals belonging to the operation in an initial value acquisition. This information and the stored network structure are important for later criteria analysis. Then the fault recognition FB enters the fault information via an internal call of the alarm S blocks into the central message acknowledgement memory in the operating system of the S7 CPU. If the S7 communication system recognizes a change in the message acknowledgement memory, it generates messages to those target devices that have logged onto the CPU concerned. This is defined when the HMI stations are configured. The message contains, among other things, the message number, the message status, and the exact time of the message occurring. The message reaches its target HMI device via the relevant bus system and interface. Via the S7 communication system of the target device and the diagnostics handler, the final process fault message is made from the message data and the database with the corresponding message texts in the target device, and displayed in standard Pro Agent message pictures. The message process for this case is then completed. Here we have shown you a run for the ladder, function block diagram or statement list language using S7-P-Diag. But the principle is identical with S7 Graph and S7 High Graph. It is just that the monitoring process here is already an integral part of the language. This means that you do not need any explicit monitoring blocks here. Let us now turn to the analyzing process that makes it possible to determine the causes of a fault. We know that a fault has occurred in the process. However, what is important for fast troubleshooting is to locate the cause of the fault as precisely as possible. Let us go back. The monitoring block has recognized that the central release signal has left its setpoint state and has sent a message accordingly to the HMI device. But exactly which process signal is responsible can only be found out through criteria analysis. If the operator on the HMI device requests a detailed view of the fault, the HMI device generates a message and sends it to the communication system of the CPU causing the fault, with a request for the initial values. Now, from the relevant instance DB, the communications system of the target CPU takes the initial values of the status information, which the addresses of the networks involved have at the time of the fault, and the structure of the monitored network that is stored there. In this way, the system can then completely capture the addresses of auxiliary networks in which an interim result has been stored, a flag for example. This holds also for the case that these networks are in other blocks. A message with this content is then sent back to the requesting HMI device, and on the corresponding mask is displayed as a signal list, ladder diagram, or statement list detail network with indication of the faulty signals. From this, the operator can now determine which signals caused this fault state without having to use a programming device. In the following, we will be showing specific details for all languages that support process diagnostics, and then the integration of Pro Agent into the HMI device. The S7-P-Diag option package extends the scope of functions of Step 7 with the option of process diagnostics for the ladder, function block diagram or statement list language. Here there are different types of monitoring available. Using address monitoring, you can monitor specific addresses in the program or directly from the symbol list on a set point level or change of edge. The task of the configurator is to attach the error definition to an assignment in the desired network and to parameterize the predefined monitoring logic in a dialog. You have a choice here of edge or level monitoring combined in each case with a delay time. You can add parameters and any associated values to the message text that is supposed to be displayed in case of fault. Now, if the monitored address deviates from its set point state, the message is displayed. In addition, through criteria analysis, you can trace the address that caused the fault beyond network and block boundaries. For general monitoring, you can monitor any signals via a freely definable monitoring logic. In other words, this logic is not part of the user program, unlike the previous case. Only if the logic of the individual operation is fulfilled will the fault message be triggered. You can design an individual monitoring logic and formulate it with S7-P-Diag specific language elements in the parameterization dialog along with the message text. For address and general monitoring, you do not need to modify your user program for the monitoring logic. With motion monitoring, you check whether physical movements in your process are being executed correctly and within the specified time. S7-P-Diag offers 4 different forms of motion monitoring. Startup monitoring determines whether a movement actually leaves its start position within a predefined startup time. Action monitoring determines whether a movement reaches its target final position within a predefined time. Reaction monitoring determines whether the target final position reached is being held stable. Interlock monitoring determines whether valid interlock conditions are fulfilled in each direction of motion. Specific programming regulations have to be observed for the concept of movement monitoring. With S7-P-Diag functions, a block is supplied with standardized monitoring networks, and it has to be linked via parameters with the application-specific addresses. It already contains the necessary initial diagnostic addresses and data structures, on which the configuration masks of the different movement monitoring types are set. All you have to do is assign the parameters to the marked initial diagnostic addresses using the configuration dialog provided. The monitoring logic is then generated by the system automatically for the motion monitoring concerned in each case. The standardized data structures make it possible to incorporate ready-made HMI masks, such as the manual operation mask, without having to do any programming. This option for generating standardized multiple-use monitoring blocks, which also adapt their instance-specific message text automatically, is a great potential for streamlining in engineering. With the S7 Graph language, the option for process diagnostics is already an integral part of the engineering tool. The possible fault definitions are integrated directly into the sequencer with the S7 Graph editor and evaluated permanently by the sequence controller at runtime. S7 Graph knows two types of error monitoring, the interlock and the supervision. The interlock is a programmable condition which affects the running of individual actions of the sequence. If the interlock condition is not fulfilled, in other words, there is an error, an interlock fault is announced, and all actions linked to the interlock are blocked. Supervision permits you to monitor the step-enabling condition in the next step. If the supervision condition is fulfilled, for example through a time monitoring step, a supervision fault is announced, and depending on the settings, the sequencer is blocked. The error texts in both types are generated automatically with specification of the faulty step. S7 HighGraph 2 has the option for process diagnostics already integrated. All fault definitions are displayed here in the editor on specially marked fault states. S7 HighGraph basically distinguishes time monitoring and state monitoring. Time monitoring indicates whether a transition switches after a fixed time. If after the parameterized monitoring time there is to be branching into a fault state, then this is done via a transition with the predefined signal ST expired. With global monitoring, regardless of the actual active state, a signal is monitored constantly or globally for its state. In the program, this means that in any transition with conditions, state-dependent monitoring is when a signal is to be monitored only when it is in a particular state. In the program, the conditional transition then comes from the monitored state and leads into the fault state. In all three types, the error text is generated automatically from the state number, the name of the graph group, and the state graph.